Ladies and gentlemen, my name is Lewczuk. I am from Warsaw University of Technology, Faculty of Transport, and today I'm going to present you some bullet points, a kind of a summary of element of a wider project that was developed on the Faculty of Transport. That was a SimMag 3D, the system for designing and simulation in 3D simulation of warehousing objects, aspects of warehouse process control and the quality of warehousing services. My presentation will be composed of a few elements. The first element is introduction to warehouse processes and in general warehouse as an element of supply chain. Then the controlling mechanisms that are applied in warehouses, and after that a few words about telematics and WMS systems and the possibility of implementing and what-if questions to that system to make the quality of warehousing services better and higher. Okay, let's start with an introduction, the warehouse service potential. What is the warehouse? I think that we all know what is a warehouse. It's a place in logistics system, in a logistics chain, a logistics network, as we call it, the place where it's where the transition of material is realized, and the logistics processes like storage, order picking, and other process increasing the value of a product and increasing the availability of a product in time are done. The warehouses are important for a quality of services in logistics systems, because this is the place when the service is done. The client takes the material. The material then is a service, and the client evaluates the service according to the timeliness, according to the number of errors, and in general the condition of a shipment. So this is the place where quality is created. So this quality must be then investigated and researched. Okay, the quality of services is connected with the potential, with the technological potential of a warehouse. Of course, it's a rule of thumb that strong, the reliable and the efficient warehouse will provide better services for a final client. And then this relation between potential of a warehouse that is related to efficiency and dependability of the warehouse can be researched, investigated, and then related to the quality of services. What is the potential of a warehouse? Is a volume of units that can be handled during the day in shipments and in supplies. It is a ability to keep an optimal, in general, the stock of the products. It's an ability to provide an appropriate information to the client. This information must be related to the state, the condition of order realized. Of course, the potential of a warehouse is related to the equipment, labor, a human resource, storage capacities, information time, and organization. These are the technical aspects, organizational aspects that must be taken into account. But can we model that potential? Can we include that potential, that models into a WMS, warehouse management systems, to use that knowledge about the potential to figure out the quality of services? What is the high quality? Firstly, in a warehouse, of course, it's an admissible number of and structure of errors. Admissible means that it can be accepted not only by clients, but the policy of the company and the policy of quality assurance done in the supply chain. The services must be done on time, and of course acceleration and deceleration of orders is possible. Then this kind of a warehouse is perceived as flexible, and this increases the quality of services done. Warehouse should be ready for material flow accumulations. This is the randomness of the reality of the material flows in supply chains. The randomness makes accumulations. These accumulations can cause the shortages of technical potential to unload, load, and prepare on time the shipments for clients. It also should respond to the changes in structure of supplies and clients' orders. It means that the flexible warehouse with a high technological potential can change its pattern of works to just fit to ongoing clients' orders. It can be seasonal, it can be long-term trend, but it should be taken into account during the development of a warehouse. And what are the issues that decrease the quality and make the problems? Firstly, it's a human error. Human error is a factor that cannot be, of course, excluded from the warehousing processes, since the people work there and since the people control the processes. Each error causes additional repair task. This repair task is additional labor consumption, additional cost, and possibly additional delay in a shipment of material. Accumulations that are caused in supply chain by the bullwhip effect and other effects related to information flow then cause the lack of technical potential in servicing of a client's orders. Some issues with reliability of equipment and internal systems in the warehouse, but this is not most important part of quality estimation of a warehouse, because the reliability of the warehouse, the system, the warehouse's technological system cannot be described simply by typical standard reliability measurements. When one forklift and one crane is sorry, I forgot the word, is broken, this is the word I was looking for, then it will not make the system stop. And what is important then, these are the data errors and information lags. The warehouse as an element of supply chain is subordinated to some higher systems, and it controls some systems below. So this data transition between ERP or MRP to systems is a way when material flows, information lags can appear, so the delay, so additional efforts to make these errors working on. Poor performance tracking. Performance tracking through the warehousing systems like warehouse management system, WCS and other that I will describe in the middle. This performance tracking is necessary to keep the high quality of information. Garbage in, garbage out. If we have a poor quality information to make planning, then this poor quality planning will make another mistakes in the future. Okay, what are the areas of warehouse process control that we can use to overcome the issues presented before? These are 5 areas. The first is material handling rules. It's an element of warehousing technology, how to direct material flows inside of a system to make this process smooth and to make this process standard without any additional tasks to react on situations. Then inventory control. Warehouse is an element to buffer material flows in supply system, so inventory control is crucial for high quality information for planning mechanisms. Inventory control is to reveal any errors in stock. This is necessary to keep the information flow in a reliable way. Then efficiency and quality of management. These are the big tools for improving the processes in the warehouses. So we have a warehouse activity profiling and controlling as tools for investigating the labor consumption and the labor distribution over the elements of the warehouse and over the elements of the warehousing process. Then error reporting by customers and cost reporting as a ways to finding out what is the cost driver in our system. The last thing, law and regulations. Law and regulations are of course important, but these are more constraints for the system than the areas where we can find out a new way of working. Of course, ESO, International Standardization Organization, and standards of ESO tend to increase the quality of the processes. What we can do to strive for the efficiency and quality of the process. These are, firstly, reorganization as a simple working, reassigning resources to the tasks in time. Then we can do some technological changes. These technological changes are, of course, expensive because they require buying a new equipment, installing a new equipment, and rearranging the warehousing processes. We have an infrastructural rearranging. It's buying a new places. It's for architecture. It's changing a building. So this is the most complicated way of striving for efficiency and quality. And of course, we have a telematics and IT. Within that telematics and IT, there's plenty of solutions, but in general, warehouse management systems and modules of ERP, Enterprise Resource Planning systems like WM, are the most common things. We have warehouse control systems. They are typically elements of warehouse management systems which are installed by the developer of WMS. We have material flow control. These are the systems for controlling the equipment like forklift, cranes, conveyors, and other things in a warehouse. AIDC, automatic identification and control systems. These are all tools that are for communicating the people on the floor of the warehouse with the systems. DWS, dimension weight scanning, SCADA, supervisor control, and data acquisition systems. These are mostly from manufacturing execution systems, but sometimes used in the warehouses. Now, how we can try using that areas of warehouse control, how we can try to increase the technological potential of the warehouse and then strive for a better quality of services. Firstly, is a technological redundancy, because buying more equipment and taking more space will provide us better results in data, but it's not cost effective. So the universalism, flexibility of technologies that can be redirected between the tasks. This is, of course, related to logistics tasks that must be solved, but it's dependent on the branch, on the industry, but sometimes using the universal, cheaper technologies can be better for the quality assurance. And information systems, just like I've mentioned before on the previous slide. Now a few words about the process itself. From the engineer's point, the warehousing process is a set of operations. These operations are done to move the material from the entrance to the exit. During that movement, some selected features of the materials are changed, like a shape, like a volume, like a number of units, like a labeling, and other things that are required in a supply chain. Of course, it takes a time, and this kind of a process is composed of so-called work orders. The work order is just one of the three possible sorry, I forgot the word. Is one of the three possible transformations of material flow: time, place, and the shape of the material. So the process can be composed as a set of movements, as a set of operations. Now, some of these movements, some of these paths are considered as standard. Standard path is a reliable way of realizing the order. It's according to the design, that was the first design before the operation phase. If the process is all done by the standard tasks, then we can expect it to be reliable and high quality. If not, if some additional tasks like this one must appear according to the lack of handling possibilities, storage capacities and other things, then it makes additional cost, and so it is not considered as an efficient way of realizing processes. Then, every possible way, every possible path of a material flow through the warehouse can be represented by the tree of events. This tree of events represents all possible transitions of material through the warehouse. They can be finished with three possible situations. This is a high quality, on-time realization, the delay with an errors, or the cancellation of a realization. Of course, we want to make the number of standard realizations the highest possible, because it will provide us the high quality of the process. Then we try to find out the possibilities, the three possibilities that describe the possibility of selecting one of these three options: standard realization, delayed realization or with an errors, and cancellation. Cancellation, of course, is the worst. These three possibilities can be found out during the analysis of data from WMS systems. Now, on the basis of that three possibilities, we can construct OTIFEF. It's one of the most important KPIs in logistics. It's on time, in full, error-free KPI on entrance for receiving the materials, and on exit for shipping the materials to the clients. Of course, that second one on exit is more important because it is related straightly to the clients that perceive the warehouse as a service provider. Now, the goal to increase the number of work orders executed according to standard paths. How to find out these possibilities, how to increase the number of standard paths? Of course, it must be done within the operational conditions when the warehouse is working, cannot be stopped and re-engineered. So we need mechanisms to collect the information and then to use them. Very often, the developers of WMS systems offer a kind of tools with no standards, of course. These are the so-called what-if tools. What if is to ask the questions, what happens when something will be changed, on some unexpected events will happen or other things. These what-if tools must forecast or give a kind of a guide how to przeciwdziałać, oczywiście. Sorry? Prevent, thank you very much for that. How to prevent that unnecessary situations. So we would want to propose a kind of what-if tool, what-if module for WMS systems to be based on the determining the possibilities of selecting the standard path through the warehousing system to make the on-time in full error-free KPI the highest possible level. The preliminary experiments revealed that we are able to determine this kind of possibilities, of course not in the detailed way, but on some level of generality, on the basis of operational data and data from logistics controlling. Of course, the probability is nothing. We can use it just to make the appropriate decision according to preventing non-systemic activities, to proper distribution of resources in the warehouse, like people and equipment, and for a process engineering and investments at the end. Now, the warehouse is a data-intensive system generating a lot of data for the databases like Marial flows. Not all of them are archives, and not all of them are accessible for in research. But another issue in that is selection of the proper data from the controlling mechanisms and from the warehouse management systems to make the proper decisions about changes in the system. And this is a very simple and actually the basic scheme of Marial flow through the system with the informatic system actions in that. We have here the first step from the ERP database and the last one with the ERT database. It's an information incoming, and this is the information going to the ERP system as a superior system for warehouse management. Now, where these modules of what if can be implemented? The first place is a place when work orders are processed. The place to find out in the very situation the best decision for this particular unit to be moved. Of course, it requires some tracking devices, a good view, a bird's-eye view on the system, and the situation of all resources on the floor of the warehouses. The second place is in re-engineering to support the changes, to support the decision according to organizational, technological, and infrastructural modification of a system. And the second place is a controlling mechanisms. Controlling is a base of tracking the performance, the capacity of a system. So then the controlling is a place when information about the standard runs can be gathered and can be condensed into information to be used for decision support. Now, a few words of a conclusion. This is the frame. The thing I presented to you is a frame for developing control mechanisms and warehouse processes. This is according to rules that we know, like lean management and Kanban, Kaizen, all these methods that postulate cutting out any inefficiencies. And this is exactly what we want to do. Cutting out inefficiency, increasing the number of standard paths. A system of that kind must work in a closed loop and use the previous runs to find out the solutions for the next things. We think that OTFFs and number of standard processes can be a base for what-if tool in standard warehouse management system. Of course, it is all related to particular construction of a warehouse management system, because in most cases they are based on best practices that include only standard processes, and this kind of tools require some kind of extension of the tools. And there is a model for maximization of probabilities in standard technological paths. This model could be a significant help in increasing the quality of services. In our other works, we present elements of that model. Thank you very much.